Dear students, today our topic is remainder theorem. Firstly, we will give it a statement. Let p of x be any polynomial of degree greater than or equal to 1. Let a be any real number. If the polynomial px is divided by the linear polynomial x minus a, then remainder is equal to p of a. Proof. Dear students, here the polynomial px is to be divided by the linear polynomial x minus a, and the 0 of x minus a is a. The 0 of this linear polynomial x minus a is a. Then simply the remainder will be equal to p of a. It means that you will have to find the 0 of the linear polynomial. Then you will have to substitute in place of xa so that we will get remainder is equal to p of a. When we divide the polynomial px by gx, for example, px will be divided by the polynomial gx if the degree of px is greater than or equal to gx and the polynomial g of x should not be equal to 0. We can find the polynomials qx and rx such that px is equal to gx qx plus rx, where either rx is equal to 0 or degree of rx is less than degree of gx. Same is to be followed here. The polynomial px, when divided by x minus a, we can find the quotient x and the rx, that is the remainder. Px is equal to gx into qx. In place of gx, we are having x minus a into q of x plus r of x, where either rx is equal to 0 or degree of rx is less than degree of gx. In place of gx, we are having the polynomial x minus a. Here, we can add for one thing from here. The degree of this linear polynomial x minus a, degree of x minus a is always equal to 1. And when the degree of rx is less than 1, it means the degree of rx is less than 1, implying that degree of rx should be equal to 0, implying degree of rx is equal to 0. Therefore, rx should be a constant polynomial. Say rx is equal to rc, because the degree of the constant polynomial is always equal to 0. Therefore, we will get p of x is equal to x minus a into q of x plus, in place of rx, we will write r. In particular, if x is equal to a, then P of A is equal to A minus A into Q of A plus R, which implies P of A is equal to A minus A is 0 into Q of A plus R, which implies P of A is equal to 0 plus R. Therefore, P of A is equal to R. That is, the remainder is always equal to P of A. Now I will give you an example. The example is like this. If we are having a polynomial P of x is equal to x4 minus 5x cubed minus 3x square plus 2x minus 1. And if this polynomial is divided by x minus 5, and if we are asked to find remainder, what we do, first of all, we will find the 0 of x minus 5. That is, x minus 5 is equal to 0, which implies x is equal to 5. So by remainder theorem, therefore, by making use of remainder theorem, remainder is always equal to P of A. In place of A, we are having 5. That is equal to P of 5. So it will be equal to, in place of x, we have to substitute 5. That means 5 raised to power 4 minus 5 into 5 cube minus 3 into 5 square plus 2 into 5 minus 1. 5 is to be multiplied 4 times. It means 5 raised to power 4 is equal to 5 into 5 into 5 into 5. 25 into 25. So it will turn out to be 25 into 5 is 125. 25 into 2 is 50. 50 plus 12 is 62. 625 minus 5 cube. It means that 5 into 5 cube means 5 is to be multiplied 4 times. So it will again turn out to be 625 minus 3 into 5 is